So arrays and strings. So until now what we have considered, the different variables that we considered was only a single variables. There was only single variables, whether and a single values for single variables was also given. That is, if we define a particular variable as integer, say integer x, then x can take only a single value, that is x is equal to some, say 20, 10, 100, etc., etc. So those values x can take. So that using these single values we did a number of operations. Now actually arrays actually is actually a group of memory locations related by the fact that they all have the same name and the same type. So in an array, if you consider an array consists of a number of elements of the same type. That is, if I define an array of integer type, then all the elements in that particular array will be an integer, will be integers. And this array will be having a single name itself. That is, if I define an array of size 100, I can store 100 elements with the same name. That is the peculiarity. With the same name, I can store all these 100 values. I don't have to go for 100 different names to store these 100 different values. So then how to go to a particular location or a particular element in that particular array? Say, I want to fetch the 50th element. I have an array which consists of 100 elements. But I need the 50th element. Then how I can refer to that particular element? That is another question. Because we have only a single name. Say the array name is x. X is having, say, 100 values, 100 different values. Then how the 50th element can be accessed? So for that one, we use a position number or an index number. So the index number gives you a particular location of that particular array, or the value in a particular location in the array. So in an array, if it is 100 elements, then each element will be having an index value or a location value or a position number. So then let us see one of the integer arrays. Say it is C. The integer array is known as C. So this is the integer array. So C0, C1, C2, C3, C4, C5, C6, etc. up to C11. Up to this, all these elements are having the same name. That is, the name is C. But within the square brackets, we are giving a specific number also. That is, 0 means it is the first location. In C, the first location starts with the 0. So if there are 12 numbers in a particular array, the last index will be 11. So C, in this particular case, the last index is 11. The first index is always 0 and the last index will be n minus 1 if there are n elements. In this particular array, there are 12 elements and the indices or the index varies from 0 to 11. So if I want to get the sixth element in this case, then I can refer to it as this one, that is C5. C, then within square brackets 5. So this is the sixth element. So this is the first element, this is the second, this is the third, fourth, fifth, and the sixth. So the sixth element will be having C and index is 5. So that is how the arrays are referred. So or the values inside the arrays are accessed using the index values. And now the array can be of any type in the sense it can be of integer type, it can be of character type, it can be float type, It can be any type, any variable type. It can be of any variable type. So in this case, this particular array is of integer type. So an integer array is this one. So it is having only integer values. If it is having character values, then the particular array is to be declared as a character array. Most of the character arrays are the strings. The strings are normally treated as character arrays. That we will come and discuss later. And this is what we have seen till now. That is, the first element in every array is the 0th element. Thus, the first element of array C is referred to as C0. C within square bracket, it is 0. So it is known as, it is called as C0. The second element of C is referred to as C1. The seventh element in array C is referred as C6. And in general, if it is the ith element, then it is Ci-1. So array names, like other variable names, should contain only letters, digits, and underscores. All the variable name conventions that we have studied is applicable for the array names also. The array name cannot begin with a digit. The position number, it is also known as the subscript or the index, which is contained within the square bracket. It is also known as the subscript or the index. So the subscript must be, it should be an integer or an integer expression. The integer expression is something like, say, x minus a. It is an integer expression until x is an integer as well as a is an integer. Say x is 10 and a is 8. So 10 minus 8, it is equal to 2. This is an integer expression. If x is some 12.5 minus a is some 2. 12.5 minus 2, it is 10.5. So this cannot be. So this type of expression cannot be used as a subscript for an array. For an array, the subscript should be an integer or an expression which results in an integer. So let us see an expression as a subscript for an array. Suppose a is 5. A is 5 and b is 6. Then the statement C, then within brackets a plus b. So a is 5 and b is 6. So it is 5 and this is 6. Plus equal to 2. This plus equal to, you know what it does? It adds the value 2 to the existing value of C of a plus b, that is C of 11. C of a plus b is C of 11. C11, and that particular value is then assigned to this C of 11. That is, this particular expression gives you C11 equal to C11 plus 2. So this particular expression mean that we have already studied. That is, this particular expression adds 2 to the array element C11. So the subscripted array name is an L value. That is, it can be used to the left side of an assignment. That is, a subscripted array name can only be given as an L value. That is, only to the left side of an assignment is only possible. Towards the right side, it is not practically possible. So now let us see the array C more closely. So that is, the array's name is C, that we have already seen. The 12 elements are referred to as C0, C1, C2, C11. The value stored in C0, is minus 45. And C1 is 6. C1 is 6, and C2 is 0, C3 is 72, etc. And finally, C11 is 78. To print the sum of the values contained in the first 3 elements, that is, if you want to add these 3 numbers, say 40 minus 45, 6 and 0, then it can be written as C0 like this, C0 plus C1 plus C2. So this way we can add the 3 elements within this particular array, the first 3 elements within this particular array. So if you want to divide the value of the 7th element of array C by 2 to assign the result to the variable x, then what we will write? So x equal to the 7th element of the array. So let me write it correctly. So x equal to 7th element. 7th element is C6. C6 divided by 2. So this will be the statement C6 divided by 2. That is to divide the value of the 7th element of the array by 2. And then we assign the result to the variable x. So how we will be declaring as well as defining the different arrays. In order to define an array, what we need is the variable type. The variable type or this particular term, that is int. In this particular case, it is int. It can be char, no problem. It can be char or it can be float. So what this particular statement means that the array will be containing only integer values. If it is int, it means the array will be containing only integer values. If it is a char, what it means is that the array will be containing only character values, that is A, B, C, D, etc. So any alphabet or 0, 1, 2, 3, that type of character, or special characters also, that is also possible. So that particular array will be containing only the character values. Then if the array is defined as a float, then all the elements in that particular array will be a float. Then the second thing that we require is, this is the variable type. This is the type of each element. Then in the second case, we need a name. A name is the name for that particular array. In the previous case, we have seen the array C. So this is scores. So if it is written as int scores, that means the variable type or the element type in the array is integer, and the name of that particular array is scores, S-C-O-R-E-S, scores. And here in this particular array, the name is name itself, Here it is GPA, that is the name. Then towards the last, what we have to do is we have to give a square bracket. And within the square bracket, you have to give the number of elements, the possible number of elements in that particular array. So if it is 9, there will be 0 to 8. The indices will be, or the subscripts will be 0 to 8. So this particular statement, int scores 9, it creates an array with the name scores, and this particular array, this scores array, can store only integer values, and the size of the array is 9. That is 9 elements, only 9 elements can be stored within that particular array. If you try to insert another element into this particular array, it will throw an error. So in the second case, it can store up to 10 characters, and the name of that particular array is name itself. And the third case, it can store up to 40 characters and 40 elements, not characters, 40 elements. And the elements will be floating point values. Floating point values can be stored inside this array GPA. And the size of this array is 40. That is from 0 to 39. All the elements, all the indices can be used in this particular case. So this is how normally the arrays are declared. That is int, the name, int or the variable type. That is the variable type. Then the name of the array. Then the size of the array. size of the array within the square brackets. So this is for declaring as well as defining the arrays. Now, there are different ways of initializing arrays. Initializing means defining or declaring means we are just creating the array and we are not giving any values to that particular array. The values being stored inside that particular array is given only when we are initializing the arrays. So the initialization can be done in multiple ways. So the initialization something like this. This is possible. Int numbers 5. So this is actually a declaration as well as initialization. Both are happening in the same line of code. The initialization is also happening during the declaration itself or during the definition itself. Int the data type, then the numbers is the name of that particular array, then this is the array size. Then 5 integer values placed with a comma in between them. That is, between each numbers or each integers there should be a comma, and all these values should be inserted inside double braces. That is, all the 5 elements are kept inside double braces and separated by a comma, then a semicolon. So if you create an array like this, the array will be stored like this. The first element, this will be the numbers 0. This will be the 0th element. And this will be the first element. And here it is the second element, etc. up to this is the 4th element, the last element. And then another initialization is without any size. Even if you are not giving any size here, if you have only 5 elements within this square brackets, then the size of the array will be taken as 5 only. So these two things are similar with the 5 as well as without the 5. With the 5 as well as without the 5. So this is possible. The square bracket without any number is possible only when you are initializing it. When you are initializing it, this is possible. So the size will be obtained. The size of this particular array will be obtained depending on the number of elements that is being initialized. If you are putting another value, say some 55 is also given, then the square bracket, double bracket comes, then the size of this numbers will be 6 because there are 6 elements that is being inserted into that particular array. Then there is partial initialization. In the case of partial initialization, if you generate an array with 5 numbers, that is the size of the array is 5, but you are giving only 2 numbers. You are putting only 2 numbers into this particular array, then what will happen is all the remaining elements will be assigned with a value 0. That is, all the locations, all the further locations will be filled with zeros. That is, there are only 2 values here, 3 and 7. So the first 2 positions will take 3 as well as 7, and the remaining positions will be treated as zeros. Now there is a possibility of initializing all the values to zeros. So suppose int lots of numbers. So this is the name, lots of numbers is the name. Then the size is given as 1000. The size is given as 1000. We may not be able to type down all the 1000 numbers. Instead, what we need is all the values to be filled with zeros. All the locations to be filled with zeros. So for that one, what we do is we put a single 0 inside the double braces. So what this does, what this particular statement does is, it will create an array with a name, lots of numbers, and the array type, the type of the elements that is being stored inside this particular array will be of integer type. There will be 1000 elements, and all the elements are initialized to zeros. So any of these initialization procedure you can follow depending on the situation that you are in. So okay, there are some examples how to initialize all the array elements into zero, etc., etc. So today I'll discuss only about initializing all the array elements to zero. We will see a program. Let me take it. Yeah. Okay. So this is the program. So we are initializing the elements to an array of zeros. So as in a very C program, what we have to do is we have to start with include stdio.h, then int main void, that is the function main begins here. Then we define an array, or we declare an array n, the size of the array is n, and I mean the name of the array is n and the size of the array is 10. The size of the array is 10 and the name of the array is n. Then we need another counter. This counter is required. This counter is required in order to trace through, or in order to iterate through the different elements in that particular array. So what we initialize this array is we are initializing all the elements into zero using the iteration procedure. That is, we are inputting zeros into each of the elements in that particular array. For that one, we need a for loop. For loop for I equal to 0, I less than 10. So the value of I, we are changing from 0 to 9. So I is less than 10. That means I is less than 9. I mean less than 10. That is I goes up to 9. Then plus plus I. This is our normal for loop that we commonly use. I equal to 0, I less than 10, then I plus plus or plus plus I. Then what we does is n of I equal to 0. N of I means the ith element in the array n. So when I equal to 0, this I will be 0. So n 0. Then when I equal to 1, this I becomes 1. So n equal, I mean n1, then n2, etc. up to n9. It will go up to n9. So each element will be assigned with a value 0. So that is what we are doing. Then what we does is we display that particular array also. In order to display that particular array, what we does is we this particular line, actually what this particular line does is it prints the value element as well as value on top as a header for our table. In the table, what we are representing is the number as well as the corresponding element. The number is the position, the subscript as well as the corresponding number, or I mean corresponding value inside our array. So for that one, again we use a for loop. This for loop is to iterate through the different elements in the array. So I is 0, then I is less than 10, that is up to 9. So 0 to 9 is 10 elements. Then plus plus I, then we printf percentage 7u. This percentage 7 means 7 spaces will be assigned for displaying that particular number. So u is a type specifier. In this case, I is given as integer. So this can be this percentage 7. D is also possible. Instead of u, you can use D also you can use, because I is an integer value. This u is for unsigned integer. So that is also possible. Then percentage 13D, that is percentage 13 means 13 spaces will be stored for or will be reserved for printing the next value, this particular value. So the first value in this case, that is percentage 7u, the I will be printed. I will is 0 to 9, 0, 1, 2, 3, etc. That value will be printed. And in this percentage 13D, the value of ni will be printed. That is n0, n1, n2, etc. All the values will be printed. So let us see how this will work. See, all the values 0 to 9, all the 10 values are given as zeros itself. That is, the initialization is being done with 0. So this is a way of giving values to or inputting the values to an array. Instead of this 0, if I put I itself here, I am putting I itself here, then what will happen is all the elements will be given as the value of that particular subscript. So 0, 0, 1, 1, 2, 2, 3, 3. So I can give it as 2 times I. All the elements will be given the value 2 times the subscript. So 0, 1 is multiplied with the 2, so it is 2, 2, 4, 9, 18, etc. So this way we can input values to an array. Instead of directly giving this values, if we use a scanf statement, if we use a scanf statement, then we can give user defined values to or user defined input into that particular values. That is, you can type in your own values. So these things we will discuss in the next class, and this is for tomorrow. We are ending the session.